Hey everyone, in this video we're going to talk about how to add or subtract two fractions. Now the most important thing when you're adding or subtracting fractions is you need a common denominator. In other words, the denominators have to match. The sizes of the fractions have to match so that we can actually combine them together. So what I want to do is take a look at a couple examples. We'll talk through the process. And then we'll look at an example where we're using mixed numbers, and we'll talk about how to handle that. So I have the reminder here, to add or subtract fractions, you must have a common denominator. So when I'm looking at this example, I have 5 over 6 minus 3 over 10. The denominators don't match right now. So the first thing we have to do is we have to make those denominators match. And the way we're going to do that is by using equivalent fractions. So what we want to do is multiply the numerator and the denominator of each of these fractions by some number that will make these match. So just as a side note over here, what I'm looking for a number that both can be divided by 6 and it can be divided by 10. A really easy way to find a number is to just multiply the two together. So 60 would be an option. But if possible, we want to use what we call the least common denominator. So the smallest number that both of these can be divided by, which in this case is going to be 30. So 30, I can divide that by 6, and I end up with 5. And 30, I can also divide that by 10, and I end up with 3. And these numbers here, these are actually what I'm going to use to multiply in my fractions to get our equivalent fractions. So 5 over 6, I want the denominator to be 30, so we're going to multiply the numerator and the denominator by 5. And I'm going to write everything out here. So we have 5 over 6, and we're going to multiply this by 5 on top and 5 on bottom. Now 5 over 5, this is like 1. So it's like I'm multiplying by 1, meaning I'm not changing the value of this fraction at all. I'm just rewriting it as an equivalent fraction. And then we have minus 3 over 10. And then for this fraction, we're going to multiply the numerator and the denominator by 3. So what we end up with, here we have 25 over 30. In my second fraction, we have 9 over 30. And now that they have the same denominator, we can subtract these, right? They have the same size. So 25 minus 9, so now we're just combining together the numerators. So it looks like this. So we end up with 25 minus 9. The denominator will stay the same. That's going to be 16 over 30. And as always, the last thing we want to do is simplify our fraction if possible. So 16 and 30, these just have a common factor of 2. So this gives me a final result of 8 over 15. All right, so let's try one more example. And as I said, in my second example here, I want to take a look at some mixed numbers. We actually have a couple of different ways that we can handle this. So I want to talk about each of those. I have 3 1/8 plus 5 2/3. Now, one way that I can handle this, and works with a lot of mixed number operations, is we can just change these into improper fractions first. So for example, let's rewrite these as improper fractions. So this first one, 3 1/8, we'll take 8 times 3, which is 24, and we'll add on the extra 1. So that first fraction is the same as 25 over 8. Our second fraction, 3 times 5 is 15. Add on the 2, we get 17 over 3. And now, like this, now we can do exactly the same thing we did in our first example. We'll find a common denominator, and we'll use equivalent fractions. In this case, the common denominator is going to be 24. So this first fraction, we need to multiply by 3 in the numerator and denominator. And the second one, we need to multiply by 8 in the numerator and denominator. So for our first fraction, 3 times 25, we get 75 over 24. And in the second fraction, we have 17 times 8 is 136, and this is also over 24. So now we can actually add these together, and 75 plus 136 is 211 over 24. And looking at that fraction, seeing if we can simplify, it does not seem that 211 and 24 have any common factors, so this would be our final answer as an improper fraction. Or I could go back and I could rewrite this as a mixed number, and as a mixed number, this turns out to be 8 and 19 over 24. So that's one way we can handle it, and that's one way we can handle a lot of mixed number problems, is turning them into improper fractions first. But another way I can do this is by looking at the whole number parts and looking at the fraction parts of our mixed numbers separately. So just to give you an idea of what I'm talking about. So 3 and an eighth. 3 and 1/8 is actually just the same as 3 plus an extra eighth. And then 5 and 2/3, that's just the same as 5 plus another 2/3. So when we write a mixed number like that, it's actually just representing addition. So written like this, addition, we know we can do in any order we want. So why don't we rewrite this? We can do 3 plus 5. So our two whole number parts. And then we can look at 1/8 and 2/3, the two fraction parts. So 3 and 5 is 8. And now for our fractions, we do need to get a common denominator there. It is going to be 24, just like we had the first time through. So we'll multiply by 3 for our first fraction, multiply by 8 for the second fraction. So we end up with, let's see, we got 3 over 24. And then for the second one, 2 times 8, we get 16 over 24. So now combining those two together, 3 plus 16, just combine the numerators. We get 19 over 24. And as we can see, if I write this as a mixed number, it's exactly the same as what we had the first time. So two different methods, two different ways that we can handle mixed numbers. Both of them are perfectly valid, just depending on which way you want to work with it and which way you want your final answer to end up.